Good afternoon, ladies and gentlemen. Your host, Golden Zulu. So today we have one interesting question which reads to say, a fair die is thrown. List the sample space of the experiment and hence find the probability of observing a multiple of 3. So remember, a die is one which has 6 sides. So I have one keyword here. So the keyword we have is the sample space. So when you are given a sample space, we need to understand what this sample space mean. So you have key terms when you are dealing with probability. You have what is referred to as a sample space and what is referred to as an event. So for now, we will just look at these two keywords. So when you are dealing with what is referred to as a sample space, this is simply a total number of outcomes you get from an experiment, while an event is a subset of a sample space. So when you are dealing with what is referred to as a sample space is the number of trials you make to get the desired outcome you want, called probability. Remember, probability, this is simply the numeric value of every experiment you make. So when you are dealing with the sample space, you are just listing what you were getting when you were having your experiment. So in this case, when a fair die is thrown, let us say you want a multiple of 3 or an odd number, you may throw it so many times. So that's what the sample space is. But we want the actual numbers which are there. No matter how many times you might throw the die, definitely all those numbers will show at one point or another. That's what a sample space is. So the numbers that will show are 1, 2, 3, 4, 5, and 6. So this is a sample space. Why? Because no matter what you will do, these will definitely show up. Yes, 3 might appear twice when you cast the die so many times, but we are just interested in how many 3s are there on the die. So still 1, 3. Then, so this is a sample space they have told us to list. Then the question A reads to say, find the probability of observing a multiple of 3. Remember, a multiple is a number in which 3 can go into without leaving any remainder. So the multiples of 3 are 3 itself. Why? Because you have 3 times 1 to be equal to 3. And you have 2 times 3 equal to 6. 3 times 3 equal to 9. But there is no 9 on the die. So we just end here. Then how many numbers do you have? You only have 2 numbers. Then how many sides does a die have? So how many sides? 6. So that is how we get our multiple of 3. If you want, you can simplify it and you get your answer to be 1 over 3. Then the big question is telling you to say, find the probability of observing an odd number. You need to know what an odd number is by definition. Remember, an odd number by definition is a number which cannot be divided by 2 evenly. So, and those numbers start from 1, 3, 5, 7, all the way to positive infinity. So, now that we have listed these odd numbers, how many odd numbers can you see? You see how many? 3. And you have how many sides on the die? You have 6 sides. So this 3 is what is referred to as the event, and the 6 is what is referred to as the sample space. Why? Because an event is a subset of the sample space. You can never the value of the sample or the value of the event can never surpass the value of the sample space. Why? Because a subset is a set within a set, so which means these 3 should be within the range of the sample space. If you were to further simplify, you will get your answer to be 1 over 2. Then the last question reads to say, are these events mutually exclusive? Remember, when we talk about mutuality under probability, we are talking about, are these events having anything in common? So if you check, 3 was there and 3 also is here. And we know to say under mutuality, let me say the multiple intersecting with the odd, we should have an empty set, but there is a 3. So it is violating the laws of mutuality. So this 3 shows to say that this multiple and this odd are not mutually exclusive. They are not mutually exclusive. So this is how we prove if events are mutually exclusive or not. So you check in the sets which you have been given. So in this case, the sets which you have been given have an element in common, and the element which is in common in this case is 3. So the multiple of 3 together with the odd number are not mutually exclusive. Your host, Golden Zulu.